Thank you very much. Yeah, congratulations to the organizers for running this fantastic and important challenge, and thanks for the invitation. Let me just go to my slides. I think you should see them now.
Yes.
All right. Yes, the title of the talk it's about multi-objective recommender systems. And as you said, this is really well aligned. There was some work I was doing recently looking at things on multi-objective recommendation. Let me see if the slide moves. Yeah, I have some materials. The slides can be found online under tinyurl.com EvalRS 2022 slides. And I put together also some sort of extended abstract, like 4 or 5 pages, where you the talk will be based on mainly on this thing here, and it's also on tinyurl Morse 2022. It's another event on multi-objective recommender systems. So I would like to start a bit also giving history on how this developed, this field, and why it's important to look at multi-objective recommender systems. So first of all, I tried to come up with some new, very generic definition of what the recommender system is and what it's good for, what's the objective. That's the point here. So I came up with this, like recommender systems are software solutions, that's clear, that provide users with convenient access to relevant content. So I tried to be very generic here. So, and the convenience might be in different things, like it guides users to relevant items in situations of information overload. You may have read that somewhere in papers. It helps users discover new things. Also, that is well known, or it's simply reminding users of what they were interested in earlier. Also, we see such type of recommendations. And the convenience might also be that the system automatically takes action and plays some tracks or videos on a streaming service. So that's a very generic thing that covers different ideas of objectives you want to fulfill when running such a system. So when we look at literature and history, from the academic perspective, we have this implicit, it's never spoken out or not always spoken out, this implicit common objective. We would guide users to relevant items. We want to surface these items in situations of information overload. So when we have many options, many musical pieces to listen to and so on, and the objective is fulfilled by, through personalized item ranking or even filtering out certain objects. And if you move on to be more specific from these abstract goals and objectives, usually a recommendation is abstracted to be a problem of supervised machine learning, and you learn a function or the parameters of a function from noisy data. And what you predict is the absolute or relative relevance of ratings or relative relevance of items for individual users. So that's the main objective and goal of recommenders. And we do this, and even going down there, we say making it specific, you have a length restricted recommendation list, let's say top N, with the most relevant items on top. So nothing new here. So, and the question is, how do we measure if we achieve the objective? We have usually these accuracy measures we all know. In these machine learning-based research works, but also in reality, what people do and companies do, organizations do, is monitor the effects on user behavior in field tests, A/B tests, or we can do questionnaires or lab studies, as we do also in the academic environment. So prediction accuracy is the single one most important objective here. And if we look at the history, and now there's a lot of papers coming out in with this boom in machine learning as well. Like this is an example of an early work. It's the group lens system from 1994. So we do this prediction or accuracy optimization, predicting the top items correctly. So since almost for 30 years, maybe earlier there's the information filtering routes. They're even earlier. So in 1994, they came up with like the system, group lens system was this email filtering system. It's collaborative filtering because you have the opinion of others. You have this matrix of users and items. And what you do is technically you predict the empty spaces in the rating matrix. And in 1994, this group lens system was based on nearest neighbors. So user-based nearest neighbors, a very simple technique by then. And I want to point you to this issue that they were building a system, like this was really a user interface here, and you have this rating interface on the top right. So people could rate if they're interested in this news item, and there were other visualizations. So it's not about the algorithms and the metrics, but it's more about the system. And I think they didn't have an evaluation in that really important paper by them. But other papers had. So rating prediction means we can, if it's a supervised learning problem, we can quantify the quality of the prediction. So here is a paper from 1995, one early one I found. They said we have to minimize the mean absolute prediction error. And then there's RMSE. Now we have more rank-based metrics in recent years for a number of reasons. But basically, the common pattern has been the same. And here I had another screenshot from that paper. You see this is a rating scale for, I think, music. So they were very creative and thinking beyond like the algorithm. It's really about a system with a smart or compelling user interface design for providing the ratings to the items. So now we can say in some ways, like we work in our community in the academic field on rating prediction and optimizing rankings since 1994 at least. And we have hundreds or even thousands of papers every year with significant improvements in every single paper over the state of the art. And interestingly, the paper still isn't solved, it seems. So we have, if you go to Rexis, KDD, or CIKM, you have a lot of papers on admittedly other types of problems, but the nature is the same. The underlying assumption of all these optimization techniques is that if we improve the objective, the algorithmic objective, like the RMSE or MRR, we have better systems. And that makes sense in some way, right? But then this might be not enough. So let's think again about this definition. We provide convenient access to relevant content. So if that's the typical example, you have these Star Wars movie lovers, and these are the 5-star rated items, like 3 Star Wars movies. And then you recommend this, which is another Star Wars thing. So is this relevant? Yeah, maybe it is. Yeah, it might be relevant for this user. The user will probably watch these movies. And the rating prediction might be very good, like 0 error, like 5 stars predicted, and the user will probably give 5 stars. So it's relevant in some ways, but there might be 0 value, both for the consumer and the provider. Like for the consumer, it's boring, it's no discovery, then maybe the user knew all these items already. And for the provider, it's a missed opportunity. You could have used that space on the screen for recommending for some other content. That would be better for the provider probably. And also, this is not new. Okay, so this is like the first I found from Barry Smith and Keith Bradley from 2001, where they proposed something to improve the diversity. Like this list, of course, is very non-diverse. Improve diversity, and there's one paper also later by the group nice people. Being accurate is not enough. It's even bad for recommender systems research to optimize only for accuracy. So this is very well known, but still, if we look at what is being published today, there is, of course, work on these beyond accuracy measures. But I don't know if you know this Twitter account, the NeuroNet guesses meme. So you give some image, upload it, and then you see what the prediction is. And the prediction here would be like there are people in a conference room, right? 100%. So nothing else to see here. And I think this is a good metaphor. Like we all know for many, many years that accuracy is not enough, right? And so it's really good that we see that we have this workshop which goes beyond and takes a novel, fresh approach to make this aware and put forward creative measures, right? So quest for the state of the art. So I mentioned 1994, it was user-based nearest neighbor. So we did, or I was involved in some project recently where we evaluated a bunch of old and new algorithms on small data sets. So we're not generalizing, but we use small data sets that are commonly used. And we found, actually some very simple models were leading here in many cases, like a Mulitstakeholder 1M, which is a frequently used data set, but user KNN is still fourth. And then we think it's a reasonable evaluation in terms of how we tuned all the models. So after 28 years after nearest neighbors, and many papers, it's not bad, right? So this also raises questions. So, but the important point for us maybe is that what we learn also from this workshop and also from others that have done this is really we should move from single objectives to multiple objectives, and like proposed also in 2001, like predicting, like one thing we have to mention is that being able to predict the relevance for users in a certain context, this remains to be important. So there's, I think, no doubt about this. It's not useless, but it's maybe one ingredient of many others, among many others. So, and because the optimizing for one type of objective and metrics, it's maybe too simplistic to have impact in practice of our research, right? Because the recommendations, they can really serve a multitude of purposes, as we discussed in the beginning about the convenience, what it means. It could be information filtering, it could be discovery, it could be simply entertainment. And all of this might lead to different business KPIs that you want to measure. And they might not correlate with accuracy measures, right? And as I said in the second part here, it's also, you have to think of the provider perspective. It's not only optimizing if it's relevant for the user, but maybe there's some provider interest here as well that you want to satisfy in parallel. And so also we put forward this paper 2 years ago. To put this together, we called it like escaping the McNamara fallacy. It's important that we have more impactful research, even more impactful. Let's put it positive here. So if we just measure what we can easily measure in academia, then we might not make progress. And this guy McNamara was the minister for the Department of Defense in the Vietnam War. At least that's the story, that the progress in the war was counted or measured in terms of the body count, like the number of enemies that were taken out. But it turned out that this measure, which was easy to, in some ways easy to measure, didn't give a good picture of the progress in this situation. So, and in that paper also, we put forward the idea that is also here in the workshop. It's like we have to have multiple objectives considered in parallel to have more impactful things. So let's talk a bit about the objectives. If you have multiple objectives, they can't be competing, right? Sometimes they're not competing. It could be synergistic. So like you have higher diversity. This might hurt accuracy maybe in offline, but it might lead to more engagement and discovery in an online setting, in a real world setting. Sometimes, as said, the objectives can be competing, like accuracy hurts diversity, making more diverse, more risky recommendations leads to lower accuracy in an offline evaluation. And in many of these papers, I think balancing these objectives is a central problem in the literature. Where the problem is, again, in academia, we have to abstract, or we want to abstract from specifics of an application use case. So we take these weights to be given. And I think we have also something related here in this challenge, a balance score that should be achieved, right? And then I tried to, looking at literature, which I want to report, and on the history, I tried to identify what has been done in that direction to show a broader perspective. So I have these three main types, saying we have competing quality objectives, as we discussed, like diversity versus accuracy for the individual users. On the other hand, there might be competing stakeholder interests. So you want to have good recommendations, relevant ones that lead to customer satisfaction in the end, but this still should be focusing on items that are also profitable in some ways, right? And the third thing, which is maybe a very difficult one, also in industry, is the temporal objective, or the time horizon. So, for example, you can in some ways easily increase click-through rates in some domains, but that would not lead to long-term customer retention. Okay, so let's look at the first part. What I found here in literature, this is some area where it's not so prominent. It's about the individual level objective. So it can be that one user has different criteria of importance. So if you're looking for a restaurant, the distance might be important, the dishes that are offered might be important, the price category might be important. So there's a class or line of research in academia that recommender systems try to take these competing objectives into account, right? So this whole thing represents a multi-criteria decision problem where you want to balance these objectives here. In many such situations, you have maybe some Pareto front, and it's important then maybe to explain to the user how the system came up with this particular solution, which kind of compromises it has been taken, and explanations might be helpful here. So the ultimate goal is for the user to find the solution, even so there's some compromises to be made. Another individual level thing in some ways is calibration, which is more popular in recent years. So the idea here is that you have a user profile which has a tendency, certain preferences. So the user, for example, likes popular movies or likes niche content or likes a broad spectrum of movie genres. So what you want is you match the recommendations in terms of this distribution. So if there's only blockbusters in the profile, maybe go for mainly blockbusters. The interesting part here is that you don't have any global target for diversity or any desirable system level objective, but rather just match recommendations to user tendency distributions. And technically, approaches have been proposed, like minimizing differences between, like, say, genre preference distributions. And there's also some relation to next track music recommendation we worked on, where we have a playlist of, let's say, 5 tracks that the user has just listened to. And then you want to make a continuation which matches different criteria like the tempo or energy or danceability in some ways. And technically, people often use re-ranking. So you have an accuracy optimized list, and then you re-rank according to the user profile. And yeah, this is also not new. So the first papers, like 2011, put forward the ideas, and it's still active. So it's an interesting idea here to deal with these objectives. A more frequent form is like what are termed accuracy versus the rest. So you have accuracy as the main criterion, finding relevant items, but then there are side goals like diversity, novelty, serendipity, popularity levels, catalog coverage, and recently, as we will hear in the second talk, keynote talk at the end about fairness, can also be in some form, depending how it's implemented, can be placed here. So what you want here is you want to increase the other objectives while retaining accuracy. So a bit more diversity, a bit less popular items while maintaining accuracy here. As said, sometimes it's synergistic. So we found that in this work on music recommendation. So it's really not finding like the blockbuster, the smash hits to recommend, which gives you high recall usually in such offline evaluations, but really find things that are coherent with the ongoing playlist. And in this study, we found that accuracy even can be improved when you apply such a re-ranking in the right way at different list lengths. So it's not always a contrast, but most of the time it probably is, right? Then there are different variations how people implement that. Often there's like accuracy versus one another objective, or you have multiple other objectives which you want to balance. Then you can also classify the literature in terms of what is the goal, how do you optimize, how is this exactly set? For example, in diversity, you can set, I want a certain target level of diversity using some diversity metric. You can use that calibration approach that you just match user profiles and the recommendation lists. Then you can say have setups where you say, look, I have an algorithm that is equally accurate than the other existing one, but mine is more diverse. Or another way, yet another way is to say, I want like 10% more diversity in whatever measure, but I only want to compromise in 3% in accuracy on the chosen measure. So there are different setups how you operationalize such ideas in the academic environment. Also, and I will not discuss a lot, but it's this explore exploit dilemma is always there. So we have, if you increase diversity, it helps exploration. And the question always is, and there's a lot of research in this bandit and reinforcement learning area, that do you want to continue making safe recommendations or help users discover things from time to time? And of course, over time, what you want is you do these risky recommendations and you hope to have more user engagement, they find new artists, new genres they like, and then they continue using the service. So, and there's a whole range of literature in that direction on the explore exploit problem. Looking at algorithms, as said, re-ranking is very, very common. So we can use any baseline ranker from simple models to complex ones and just take the output and re-rank to maximize or the diversity goal, for example. And re-ranking usually it's fast, simple, and very effective. You can use greedy methods, and we also did that. And often you can do it very quickly under the limited time constraints that you have. And the solutions, when you compare them to the true optimum, are often very close to the true optimum. But there are other techniques as well. There's these modeling approaches where you have the different criteria somehow integrated into the loss function, and then you can consider jointly several quality factors. with the problem, this might be tied sometimes to a specific algorithm, which is not the case for re-ranking. And also you have no global guarantees in such situations probably. And then there's a line of research. They model this mathematically as a multi-objective optimization problem with the classical approaches, also with a lot of like constraint-based systems. And then you compute these Pareto optimal solutions where you cannot increase one dimension without hurting another one. Often it feels like some of these approaches, if they're using traditional optimization methods, they run into scalability issues because the space of options is just too large. For offline evaluation, this is very common. So you have typical measures like intralist diversity, you have pairwise similarity comparison, and as said, you can just try to increase that measure without compromising accuracy. But the one problem, as in all of these offline evaluations, is that how do we know that this is representative? Now, do you know if a higher diversity in terms of the genre of movies would lead to a perceived increased diversity? Or for if you take that intralist diversity measure, which is just the sum of the pairwise similarities of items, would users notice a difference, or would the positions matter? And we did some minor work, preliminary work, to see if we position the diverse elements at the very end of the list, people won't notice probably. So the perception of the diversity depends also on the arrangement of the list. And then the other question, well, what's the right level of diversity? So is 10% diversity good or bad? So how do we know? And also, if you think of calibration, which is more popular in recent years, so how do we know if users would prefer this? So maybe they don't notice. So that the offline measurement problem persists. And there's also, as I mentioned, the fairness is a recent topic, and we will learn more about later on. And also there we have this problem of the metrics, at least some research that we looked at. Sometimes it's based on popularity distributions with the assumption that recommending niche items or less popular items is only fair. And we felt when we looked at this, or I looked at this as a not expert in this field, there's again substantial limitations of these offline evaluations. There's no validation of the metrics like for diversity. Also, the basic assumptions like less popular items, it might just not be good quality in some ways, right? And on the other hand, if you look at reports from industry, like from Netflix, there's a famous paper there, they say after doing all the fancy relevance prediction, they add a healthy dose of popularity. So they avoid actually in some ways to recommend things that are too unfamiliar to people, right? And in some papers we see, I felt like, okay, achieving that fairness goal, which is just a target distribution, is almost trivial. Like with re-ranking, this is well known, right? And there's this danger all in this offline that we face, unfortunately, this abstraction trap, which was coined by some other people earlier, in general explanation of AI. So we abstract maybe too much. Of course, it's important to abstract in academic words, but we shouldn't overdoing it, right? So here's another example also by Michael, the second keynote here. Like they did some user experiments on perceptions, which is really important and should be also in the focus in the future. So they compared the output of different algorithms and then let people say what they think about this. And just to give you an idea, so there's some work here where we see how factors play together, like you increase novelty, how does that impact satisfaction? If you increase diversity, how would that, what would happen here? And like here, and it could be that if you add too much of one thing, then it hurts satisfaction. So this balance, which you take as given in computation experiments, we see like 5% more, it's not easy to understand when there's too much, which would then drastically and negatively impact some other factors. So this is just to point out it's important that we must go beyond these offline measures at some stage, and otherwise it's still a bit feels incomplete. That there's some other question, which I call system level or engineering related aspect. So it's also a general question. So what we don't know also for accuracy measures, if we increase an offline by 2%, what does it mean in practice, right? Would it really matter for anyone, right? And then at the same time, this system engineering level, what's the price for the better model? So the most accurate model in offline might be very complex computationally and may not scale well or take a lot of effort to get it running. It might be difficult to explain, it's difficult to scrutinize when there are problems. So there seem to be trade-offs, so multiple objectives in a very different way, not in terms of the recommendations, but the compromise between complex models and high accuracy, maybe. It's a side topic. But let's move on to the other two categories. So the first one was like different quality things. Now the others will be a bit shorter. So we have competing stakeholder objectives. And again, from the historical perspective, it was really consumer value. So we say implicitly, if we have better, more relevant recommendations, then this would lead to higher consumer satisfaction. And this is in the end good for the provider because they purchase more, they come more often. In reality, of course, we know that recommender systems are there for a purpose, and they could be more business-oriented, more directly business-oriented than just this customer satisfaction thing. So maybe it's really about increasing sales, and this is what is actually measured then, or customer engagement, or you want to change consumer behavior. And then you have these potentially competing objectives there from different stakeholders. And there are examples, and it's also a growing area, I think, important one. So you have scenarios, we have two stakeholders like consumer and provider. And there we identified a number of works on price and profit aware recommender systems. So one idea here is when you have two items that have the same relevance for users, but one gives you slightly more profit, then why not recommend the one with the higher profit for you, right? It's not even a bad business practice. So it's the same value for the consumer. Or there's cases in an existing discount where you have a discounted items that you recommend. The chances that the recommendation is accepted will go up probably, and we had evidence for some data for that. So there are compromises to be made. There are also very special cases like social recommendation on when you recommend people to follow and so on, if you have job recommendation or dating recommendation, online dating. In particular, the last ones, they have really these interesting reciprocal aspects that you have this mutual compatibility there. The stakeholders are there. And online dating, I think, is really interesting because of course, there are two partners who want to be matched maybe, and how you measure that match success in life later on. And what's the interest of the platform provider? They're probably interested that people stay longer on their dating platform. So who knows? There might also be competing things, very interesting ones. So multi-stakeholder is something, a different form of multi-objective optimization. In history, there's also this specific scenario of group recommendation. This has been studied for many years. So the idea here is a bit different, so that you have a group of stakeholders, similar stakeholders, like a group of friends, and you want to make recommendations to them for going out to a restaurant or watching a film. So you want to consider the preferences of all these stakeholders. And there's a number of technical solutions there, often just trying to aggregate the individual preferences into the global recommendations. And the unique aspect compared to this other multi-stakeholder thing is that here all the stakeholders get recommendations and they all get the same recommendation for the same hotel. So there's also some side topic, which is slightly different twist on multi-stakeholder. Also here, similar to the other approaches that we discussed, it's a lot of offline experiments, but this is clearly not enough, I think, because there's group dynamics, there's all sorts of things that influence how groups make decisions and how people are happy with the decision. So there are some studies, at least now, that use observational studies and see how people really act in such things. So it's an interesting problem. For multi-stakeholder, so it seems obvious, but there's not much research over the decades. And the problem always is, at least for business-related aspects, there's a lack of real-world data. So business profitability data is never shared. It's confidential. It's critical. So, and then you have to make a lot of assumptions regarding what the optimal balance for a given setting would be. And then you have this final thing, which is very important. You have these longitudinal aspects, right? So if you have a not well-balanced approach, then you in the long run, you might run into problems. But nonetheless, it's good to see that these multi-stakeholder topic comes up, and hopefully we see more of that also in the future with better data or better validated assumptions. But let's move on to this last part about these longitudinal aspects. There's also very little, and if you think of the standard evaluation approach in recommender systems, where we have the supervised learning problem, you have trained test splits, and then you make predictions for one point in time, or not even for a point in time, but if you do random train and test split. So you don't capture these longitudinal aspects here. So the background here, and this is, I think, quite obvious, is that it might be, or it may be easy to, in some domains, to easily increase the key performance indicators of the organization. And I have these 3 examples. So for hotels, and I know this is an oversimplification and doesn't hold for any for every platform, but on a hotel booking platform, you might recommend relatively cheap hotels to maximize the revenue. Right? So people purchase discounted things maybe. In news recommendation, you can just recommend recently trending items, celebrity gossip, and you get all the clicks that you have. You can even use clickbait headlines, so you get maximize the number of the CTR, click-through rate, as a key performance indicator. For music, you can recommend Ed Sheeran to everyone. So everyone loves Ed Sheeran, you're on the safe side, more or less so. In the long run, of course, and you get the clicks, you get the listening events, and you get the transactions. In the long run, like on the provider side, revenue might not be always the goal. So if you just have cheap hotels, you maybe have limited profitability. For news, people might click on the items that you recommend, the clickbait, and then yeah, they don't like it. And after some time, they would not come back because they know there's nothing behind this. So you optimize your short-term KPI, but then they don't use your service anymore. For music, the same. So you play Ed Sheeran every day, which is fine. Many radio stations do that. But maybe you then also, you lose interest. You discover nothing new. And then you decide, maybe I don't need that service. I can listen to trending tracks on the radio. Yeah, there's a question. I'll put up the slides, the links to the slides at the end again. Okay. So this, I think, is very important, and others have worked on this before, but there's not so much, not so much research so far in this area in academic environment for reasons. And also, if you look at the reports from industry, so we surveyed once what industry publishes about their experience with recommenders, about their KPIs. They also only report like we did an A/B test for 6 weeks, yeah, which is in some ways long, but it's not really covering this long-term thing. But we see some uptake on the topic in recent years. So we have different forms of simulation. Of course, in academia, we don't have that, these real-world systems. So there's a lot of transition in these reinforcement learning-based approaches where you simulate different steps over time and the rewards. And there's some agent-based modeling. Sometimes we also have multiple stakeholders. And there are even works that look at, try to approach the problem of the customer lifetime value, which is an important thing in practice in many businesses, of course. Here's one example from our own work from 2015 and 2013 earlier. So we're studying different sort of biases and effects of recommendations. So here we focused on this one slide about concentration effects. So the idea is you have algorithms, some of them, they have, let's say, a limited level of personalization. So they recommend more or less the same to everyone. If you take a most popular item recommender, gives you the same items for everyone. So in this simulation, what we assume would happen is if you have a narrow range of things that you recommend, we assume that people with some probability will pick some of the recommendations. They click on whatever you show them, maybe, right? That's the assumption from time to time. So then people will take these items and they will provide ratings. You get interaction signals that you can use. And if it's a narrow spectrum of things that you recommend, you get a narrow set that gets exposure. You reinforce that thing, and the concentration might be it might be intensified then, right? And what this figure shows is not important to understand the details. So all these lines stand for different algorithms. We have as a measure the Gini index, which is a measure of inequality, which measures like the distribution if there's a concentration of a small set of items, or if a recommender has a broader spectrum, and how this develops over time. And the important message of this figure is there are some algorithms, like if you use PopRank, the orange one, it just recommends more or less the same to everyone. The concentration strongly increases. if you assume that people click on these recommendations and feed back the information. But the interesting part is some algorithms have a different tendency. So they help diversify things. And there was also real-world studies that also show that recommenders can lead to a concentration effect, that the rich get richer and get even more interactions, and this reinforcement loop also exists in reality. So this is some very simple simulation, not without agents. Here was another side result from that paper. It turned out that also what the recommender recommends, if it's diversifying or not, or concentrating or not, can depend on the hyperparameters, how you tune it. So if you look at that, so this figure now shows the number of training epochs or training steps, and the orange line is the RMSE. So you would optimize maybe for this and just stop here after 60 training rounds. And then you might conclude like diversity of this algorithm is low, but if you continue tuning, which you won't do for RMSE because maybe it doesn't give you too much, or it gets worse actually, but you see it diversifies. So it's an interesting situation that during training you can already, for some algorithms, influence other quality factors, right? And it's an interesting finding. And in some cases, it even depends on the training procedure that you use. We did the same later on also for session-based recommendation, where you don't have these long-term user profiles, but you rather have like this few clicks in a session, and then you optimize for that. And what we studied here is, again, for the music domain. So we benchmarked, so we measured again Gini on coverage and the average popularity of the recommendations. And the interesting part is, so we have this CIKM method, which recommends popular items more or less. And of course, you see increases here the concentration. It leads to high average popularity of the recommendations. That's very clear. But then we see different other algorithms. We have a nearest neighbor method called KNN, which is good, relatively good in accuracy, recall, for example. And we have two deep learning models like NARM and GROOVE-REC, which in accuracy, maybe they're about the same for this data set, yeah? But they have very different behavior. So we found this phenomenon that one algorithm or three algorithms can have more or less the same accuracy values, but they produce very different recommendations, leading in the end to very different long-term effects on what they recommend when this reinforcement has taken place. There were some agent-based simulations, so it's not like we take some data and feed it back. Here's one by Zhang and colleagues, where they used, let's say, an agent-based approach, where the users are the agents and the providers are agents. So, and their study of these longitudinal simulation, they had something like what they call the performance paradox. So they describe it as the user's reliance on the system's recommendations to make item choices tends to make the recommender system less useful in the long run. So the more people trust in the system and use the recommendations, the lower is the value of the system in the long run. So which they saw, this is called a paradox, right? So and also they observed that the consumption diversity goes down, maybe because of these effects that algorithms learn and reinforce the concentration over time, and then the value is reduced in the long run. And they use this agent-based modeling approach, which has been used in many other fields, also in economics. And we also did very recently, one such agent-based simulation study, where in contrast to the previous study, which mainly focused on the user side, we had also a provider agent, and we had also social media saying. So the assumption is that, and we wanted to study this profit awareness or price and profit awareness. So we assumed in that simulation that every item that the system recommends has a profit margin, and the provider can run different strategies, either more focusing on profit or on consumer relevance. And with this study, with the simulation study, we want to find out, okay, what's the long-term effect on cumulative profit, or would the trust decrease and so on. So what we thought here of as assumption is that the agents receive recommendations. So the users are the agents plus the recommender agent, but the consumers, they make choices, and they have some internal consumption probability. So if they would consider a recommendation and maybe make a purchase or listen to something, it depends on the previous experiences, if the recommendations were good or bad. So they have, in their decision, they have their own past experiences. So you can imagine if the recommender just recommends stuff that's high profit but not relevant, the trust will go down and the consumption probability will go down in effect. Plus, we modeled some social reputation, saying that people from time to time they share their experience on a forum or on social media, and this might influence also other consumers when they read about good and bad experiences there. And for the simulation, again, it's not important to have all the details here. The idea is here we did 1,000 simulations, and we have each line corresponds to a different strategy. So we have like the black one is the profit-centric, just recommend, this is just an extreme case, a boundary case. You just recommend always the most profitable item to everyone, right? But then you can recommend just popular stuff, or you can recommend those consumer-centric means with the highest predicted rating value in case of these movie ratings. And then you have these balance things. But what the simulation shows is that, okay, we see here for some strategy, consumption probability goes up because people have positive experiences, they like the recommendations, whereas in other cases, this goes down, right? And the interesting part is in the long run, when does this pay off here? So you see just being profit-centric works well in the beginning. People just pick, and the trust gradually decreases, and then only over time the cumulative profit will be better if you consider consumer relevance to a large extent. Of course, there's a lot of assumptions here in modeling, but it helps you understand. It's not about understanding accuracy or something, but really about this emergent behavior and cumulative effects here. So the last part, which is not in my taxonomy previously, so this completes the multi-stakeholder longitudinal stuff. There's also multiple objectives, and this is a very different topic, on the user interface, which we haven't talked about so far. So if you what you show to the users is also something, it's not given, it looks naturally, or it shows just the items and people can click on them, but there's more interaction. So the question is, how many items would you show? Like 5 items, 3, can you scroll to 200? So you can have like a compromise between information completeness and information overload. Also, in terms of the user interface, you want to make things transparent, providing explanations. There's research on that a lot recently, but this can be very cognitively demanding. You can even ask users to give them the opportunity to give feedback or influence the strategy. Again, this is related, comes with additional cognitive effort. And many other things on the UI level may have competing design objectives, like here for the conversational recommenders, let's say about chatbots implementation. So do we have natural language input, or should we have like buttons and things to click on? And also that can be competing objectives in the overall design, which leads me back to the original problem. We should think beyond the algorithm and also on the surrounding factors, multiple stakeholders, business constraints, plus also the user interface here. And we have this taxonomy in the end, where we have different competing objective types, quality objectives, multi-stakeholder, the time horizon, user experience, and we also talked about the complexity and the value that you get from these complex models sometimes. This leads me to the last question, and I think I hope it was helpful for relating academic research to the important workshop and challenge that you run here. So in practice, recommendation is not a single objective problem. It's accuracy rest, multiple stakeholders, and so on. But if we in academia want more impactful research, we should really look beyond this accuracy optimization. And this is nothing new, of course. We still have troubles in terms of data sets that we have. We need better cooperation with industry. There is some progress in simulation, like I showed you with agent-based ones and other ones, but of course with a lot of simplifications and abstractions we have to be aware of. And overall, we really should be clear that there are many abstraction traps that we hopefully can avoid here. So thanks for the attention. It was my pleasure being here. Here's my contact data. Here again, link to the paper and link to the slides. Thank you very much. Time for questions.
Thank you so much, Dietmar, for the fantastic talk. So for the people joining us on Zoom, please write your question in the chat, and we can read them out loud, and so that everybody can see them. And for people here, you can just basically walk to the podium and ask your question if you have a question. Is there any question, Federico? I know you have one.
Yeah. So I find it very interesting, like super nice talk. I find it interesting the part of like accuracy is not enough, and like that is something that is like has been said for like many years. Do you have any idea why it's difficult, like to shift towards a more multi-objective paradigm for the community? And is this related? Like I saw the summary. One of the points in your summary slide was about like the lack of data sets to do this kind of work. Is this related to the lack of data sets? Like it's just easier to use common data sets that people have been using for years, in which you can either optimize for accuracy and publish the papers?
Yeah, I think it's related. So one reason, sure, in many domains of applications of machine learning is the data sets limit what we can do reasonably as researchers. And the other thing, this is much more difficult to change, is it has to do with the publication culture, incentives in our community, traditional paths. So I'm doing user studies many times. It's very difficult. You have to defend every tiny bit of your design. You have to have hypotheses. If you go for accuracy optimization, nobody will ask any question about if that's useful or not. So it has to do with ourselves. We should be more, including myself, we should be more creative about the incentive system to get a paper published at top level conferences is a different one.
Yeah,
it seems.
Yeah, that makes sense. I have like another quick question that is more related to like the objectives. I feel that like one of the difficult things when you have multiple objectives is that they tend to be competing objectives. So like optimizing for one makes you lose a lot of like somehow capabilities on the other one. Have you had any insights about this? Like I think that is one of the most difficult problems, because in relation to the data sets that like are meant to be used to optimize accuracy, when you try to optimize other metrics on those data sets, you get definitely lower accuracy. And even if your system is in general fairer, you get worse performance because of how the data set has been structured.
Yeah, I think we should do, like, it's a trivial advice. We must do studies with users. So doing recommender systems without users, the question is how far can we really get with that, right? So, and all this fairness research, it's important, yeah, but we need validations for these things. And again, the system as it is hampers us to do this. It's good to see there are a lot of, now we have case studies in these technical papers. Sometimes we have some smaller user studies. These are good steps, and we should follow these steps. But even for accuracy, we don't even know if we have 3% in accuracy. What does it mean? As I mentioned on some of the slides, it could have the effect that you have high accuracy, but it's a limited level of personalization for some reasons, or something else happened. So
yeah, thank you so much.
Can you hear me, guys? Can you hear me? Yeah. Like one data points, Dietmar, from the trenches. It turns out that in many cases, if you improve slightly click-through rate or accuracy, however you want to measure as a information-driven metrics, it's very hard to improve business metrics. Like, for example, revenues. The reason for that, which is trivial if you think about it, is that's because people will click on things that you recommend, but they will find them anyway.
Yeah.
So when you work with real data, you quickly realize that there's, two different type of people in a website: people that are shopping, basically, and people that are wasting your time, which are the vast majority. And so people that are shopping are very determined in actually finding what they want. So the recommender system, it's debatable how much important that is. But then, and I think it's another point that you touch upon, which I think is super interesting, is I don't think that's the only dimension. There's a dimension of, like, for example, brand awareness, user experience, general pleasant like experience for the shopper. And a good recommender system, even if it doesn't make you money now, it may make you money in the future in some sense, just because people are happy to be around. But at least in our setting, is impossible to measure. Like, the long-term impact is very, very hard to measure in like, even when you have the data, like even when I can actually open a website and look at the data, is actually very, very hard to measure.
Yeah, it's very interesting. I also heard that often in businesses, it's not even clear. There's debate internally what the KPIs should be. And you have conflicts in short-term, long-term objectives also. Yeah.
Just going, with the trivial one, like conversion rate and, like average order value, like, the one that's somehow indisputable in some sense. It's actually hard to make them better. It's much harder to make them better after it's a plateau, of course. Like, If you don't do nothing and you do a recommender system, it's going to have a huge increase. But like increasing after that, it's actually hard. I want to ask one more question if there's no question from the audience. So thanks so much for the talk. Fantastic sum of reference that we can steal.
It's mostly my own.
That we can steal from our people. Yeah, of course, we're going to cite you back. So at the end of the day, it was a good move. But my question, which is kind of related to this, is that we did our best with this challenge, of course, and we given the constraints and what we could do. But one problem that we feel strongly about, I think Tobias feels very strongly about, I think Yubin, which is here, I think feels very strongly about, is the difference between when you test stuff offline, as better as we did in the challenge, and then online, especially for some metrics, like for example, fairness or diversity and stuff like that. If the only gold standard that I have is what actually happened, and there's no counterfactual that I can actually make, it's very hard to evaluate this. Do you have any, aside from simulations, which I understand the heuristic value from that, but it's very hard then to translate them to to kind of real world. Do you have any suggestion how we can bridge the gap between offline and offline, at least for some of these objectives, or is just such an open area of research that we should just get to work?
Yeah, if I had that advice, I think people, at least every industry I talk with, they always say they, not even for their specific use case, they have troubles to finding a good proxy in offline that then matches their KPI. So I don't have a solution to that. Nonetheless, I think this workshop, this is an important step, right? It's raising awareness. It might be, come with limitations of this offline thing, but then we gradually move forward, and then we start validating in some domains the metrics that we use offline, if they're good proxies for user perception or effects on business, on people behavior. But it's in reality, it's such an interesting topic and such a challenging topic. So it's a sort of sad or disappointing that like 90% of the papers just do this accuracy thing, which is important, of course, but there's so many other interesting things, I would say. And so I have no solution, but I think it's important that this workshop takes place and industry comes and shares more. And this is something that I feel also make as some sort of feedback. Also, it's sometimes a bit disappointing in industry tracks that the industry comes and says, like, here's a clever, smart model, instead of saying, here's our problems. So I appreciate that there's some input now, a lot of input from industry here.
Thank you. Yes, if you find ways for us to get more citation for accuracy, we will super be happy to listen to. Now, like, jokes aside, like, yeah, our dream is like at some point people, instead of reporting the tables with with 5 lines and there's 1 line in bold, and the line in bold is your line, there's also another table that is explain, why we're better just because, again, we're better with the blockbuster, we're better because we're better than cold start and so on. And right now it's still very hard to find good papers on that. So yeah, so we couldn't, I mean, of course we couldn't agree more. Otherwise we would never organize this. I think it's time, like, if there's no other question, we thank our speaker. Thanks so much, Dietmar. If you want, I know it's getting late afternoon in the old world, but if you want to stick around, we have a couple more hours of interesting stuff. But thanks again for joining us and for the presentation. Yeah, thank you. I fear I cannot attend a lot, but I try to be watching as much as I can. Thank you very much for the invitation again. Have a good day, and congratulations to the workshop. Thank you. Well, yeah, we'll be in touch for sure.